Okay guys, in this video we're going to focus on composite functions again. And so let's recall that composite, is really of putting together things because we are going to compose a couple of functions. So essentially, in a nutshell, let's recall that a function is just a fascinating rule, we usually call it like f, that just takes an x value and sends it over to a y value, which I'm going to express instead as just an f of x value, but we get basically an x value undergoes some transformation into a y value. What we're going to do is we're basically going to be taking these f of x values, which are the range values of the original here, and I'm going to ask you to plug them into a new function. And we'll just call this, for the sake of argument here, we'll call it g. So essentially, the range or the outputs of the original function, they get stuck into g, and what we get is some g value, but at that f of x value, which is a crazy thing to see. We say that we have g of f of x. Just like if I had a function, say g of x equals 2x, I'd say g of 1. Well, that's pretty stupid, easy to do. We'd say everywhere I see an x, I put a 1. I get 2. How about g of triangle? Okay, it's a little weird, but I would say it's 2 triangle. Okay, what about g of f of x? You guys, this is pretty stinking easy. You just say it's 2 of these f of x things, because everywhere I see an x, we're just going to go plug this in. So first things first, let's take a look at the instructions up here. With these 3 sets of functions, what I want to do is find f of g of x, g of f of x, f of g of 2, g of f of 2. And you notice how I said these things. This little o right here, we just read this as an of. So the first thing I want to do is underneath f of g of x here, I want to rewrite this as f of, and what we're doing is we're plugging g of x into f. And that's kind of a dark purple there. Let's lighten this up a little bit here. We're plugging g of x into f of x. And for g of f of x, you should always rewrite this as g of f of x. And for f of g of 2, let's rewrite this. F of, well, we're plugging g of 2 into it. And for g of f of 2, we're saying g is the function we're plugging f of 2 into. So if you've ever been in a math class, especially algebra, and all you had to do was go plug something into a function, man, this is your favorite day, because all you got to do is go plug stuff into one another. So for this first part, at least for number 51 here, we have a couple of functions, f of x, g of x, and we see that f of g of x, which we always rewrite first as f of g of x, is really what we're going to do here is we're going to plug g of x into f. So just like you would plug in a number into f, we say that the rule for f is 2 times whatever I'm plugging into it, which in this case is g of x. So I would advocate for actually writing 2 times g of x, because right next door what we're going to write is this. We're going to take g of x, which its rule is x plus 7, but we're just going to go plug that in and really make a substitution for g of x here. We get 2x plus 7, 2 times x plus 7, which ends up being 2x plus 14. Now I want to put a box around this, because this is the function we get when we plug g of x into f of x. We just say it's 2x plus 14. Now, going the other way around, if I said let's find g of f of x, which of course you would want to rewrite first g of f of x, we're plugging f of x into g. It's going into g. So what's g's rule? Well, g says take whatever you're plugging into it plus 7, add 7 to it. And so here's the thing, you need to use a blank set of parentheses first. And we say, well, everywhere I saw an x before, well, my function's telling me I got to go put in f of x. Well, what is f of x? Well, let's make our substitution. F of x was equal to 2x, so I'll put in a 2x there. Really, I just get 2x plus 7, and I also get a box around this, because I also get a happy dance, because I'm right. That's what I wanted to get. Plug f of x into g. Now, I'm noticing that I'm running out of room here. And so what I'm going to do is I'm going to leave 53 for you, and we'll call it eminent domain. I need this space over here, so the government's going to take it. So here we go. We want to find now f of g of 2 or g of f of 2. When I write f of g of 2, we're not going to run it with that funny little o. We're going to say that I'm plugging g of 2 into f. Now here's the cool thing about it. If this is a number, we're going to evaluate the inner function first. Evaluate inner function first. And what I mean is, you guys, we could just go find g of 2. And so g of 2, given a rule here, g of x is x plus 7, well, I suppose everywhere I see an x, I'm supposed to go plug in a 2. We get 9. So the simple fact here is that g of 2 is equal to 9. Then we're going to just go back over here. We're going to rewrite f of g of 2 instead of just f of 9. So really, we're saying that the output of this inner function now becomes the input of the outer function now. We're just going to go plug 9 into f, and we get 2 times x. Well, 2 times 9 is 18. So f of g of 2 really is 18 because g of 2 is 9 and f of 9 is 18. You get f of g of 2 is 18. So let's try this now. We want to find g of f of 2 as well. So I'll kind of block this off here. We say g of f of 2, which is, rewrite it first, g of, let me change colors here, f of 2. We're going to go plug f of 2 into g. Well, first things first, let's go find what is f of 2. So if f is x plus 7, well, this just became 2 plus 7, which is 9. Okay, great. So f of 2, sorry, that's g of 2. I used the wrong rule here. F of 2, just to be clear, I looked at the wrong one. F of x is 2 times x. So we would get 2 times, our input here is 2. So when I plug this in, I get 4, which is not what I got the first time. It's 4 this time. It's right this time. Since f of 2 really is the same thing as 4, then what we're saying by g of f of 2 is we're really saying that I'm plugging f of 2, or 4, into g. And so g of 4, now I get to use this other rule, x plus 7. But we're just going to go drop in our 4 here. We get 11. So long story short, we say that g of f of 2 is really g of 4, since f of 2 equals 4, and we get 11 here. Okay. So let's take a look at number 55 down here, because, well, this is a good example, having a square in one of our functions in the algebra that's involved. So again, let's go ahead and start with letter A, I suppose. We want to find f of g of x. So we're plugging g of x here into f of x. So if our rule for f of x is 4 times whatever I plug into it and take 3 off of that, then what we're plugging in here is g of x. Now, after you do enough of these, you start to see after a while, well, you know, can't I just start writing, like, you know, 5x squared minus 2, instead of having to write this step right here? And actually, you can. So at this point, we just simplify it. I notice that I can distribute here. We get 20x's squared minus 8 minus 3, which ends up being 20x's squared, but minus 11. So this is our f of g of x. Now let's go find g of f of x, which is going to be a little bit more involved because I'm plugging f of x into g, and g here has a squared input. So everywhere I see an x in g, we're going to take it out, and I'm going to put in f of x. So to simplify this, basically we're going to make a substitution. We know what f of x equals. It's 4x minus 3. Now here's my unfavorite news, okay? We have to actually not square both of these, can't do that. Not distribute your 5, you can't do that either. You need to FOIL this out. So we get equals, I'm going to buy some more room here. We say 4x minus 3, 4x minus 3, and then minus 2. So what I'm going to do is I'm going to start actually by, let's do this. Let's do the 5 last. I'm going to FOIL these out and see what I get here. I notice I get 4x squared is 16. 4x times 4x is 4x squared, is 16x squared. And then I get minus 3x and minus 3x, or minus 12x and minus 12x here in the middle, minus 12x, minus 12x. And then I get negative 3 times negative 3 is a positive 9. So I'm just going to go ahead and combine my like terms here. I told you it was a little bit more involved. We say this is really 16x squared minus 24x's plus 9 constants minus 2. Now we have to distribute our 5 through. I know you're all super excited here, but we get 5 times 16. That's 50 plus 30 is 80x squared. 5 times negative 24, well, that's negative. 5 times 20 is 100. 5 times 4 is 20. So I get negative 120 x's, and 5 times 9 here is a positive 45. Well, I'm going to save myself another step of writing here, and I'm just going to say that, hey, you know what, this really right here is a 43. So this function right here, 80x squared minus 120x plus 43, that would really be our g of f of x, okay? So it's important that we can plug another function into another function, a function into another function, because we're going to be looking at inverse functions today also. So plugging those in, let's take a look at f of g of 2. This is going to be much easier to do, and g of f of 2, just because the first thing we're going to do is just go evaluate our inner function first. So g of 2, we say, well, what is g of 2? Well, let's go find it. G of 2 would be, well, I suppose, 5 times 2 squared minus 2, it's not plus 2. So I get 5 times 4 minus 2, or 20 minus 2 is 18. So if g of 2 is 18, then really what we're saying here is that this is equal to f of 18, which if f is 4 times our input minus 3, we'll just take 4 times our 18 minus 3. So let's see, 40 plus 32 is 72 minus 3. Sorry about the mental math there, but we get this. So f of g of 2 is really equal to 69, because g of 2 is 18. So f of g of 2 is really f of 18. We get 69. So now g of f of 2, let's go evaluate f of 2. I'm going to borrow this space here. We say f of 2. The rule is 4 times my input plus 3. That's what, minus 3. Minus 3, you guys. But we're going to go, instead of plugging in x, we're going to go plug in a 2. So in this case, I get 8 minus 3 is 5. That was a lot easier to do this time. So if f of 2 is 5, then g of f of 2 is really g of 5, which I suppose we get 5 times 5 squared minus 2, which is really 5 times 5 times 5, which is a fun little cube number there. We say 123. You guys, 123. That's our composite function value. So take some practice here to get used to, but you're plugging a function into another function. And if it's numerical, we just evaluate from the inside out. Find the inner function, plug it into the next outer function, plug it into the next outer function if there's more than 2. Cheers.